here I have the sharp stereo, sort of like a 3-in-1, except that there's no record player, it's just a CD, radio and tape. And what model is it? Okay, there it is, CD-S370. So it had the CD player doesn't work, the laser. So I've cleaned it and it still didn't work. I cleaned the lens, and what I did, that's a current, the laser diode current adjustment. I slightly turned it half a millimeter more forward, and it started to work. So either that or this has to be replaced, but I'm not sure if I can get one for it, a complete laser system. So now I'm fixing the display, because the display doesn't show, so the backlight must be no good. Probably it's got globes, so I'll just have to take the whole thing apart, as you see, and that's the rest of it there. Okay, which I had to remove it all, take it apart. As you can see here, a lot of screws. Okay, and just to make sure that these brackets go. Like that, and like that. Okay. Okay, the backlight is going to be a bit of a pain to fix, because as you can see, I took the circuit board here, so it must have globes behind this. Strange that they done it like that. So I might have to take the shield off here. It looks like you have to take the whole LCD screen off. I'm not really sure if this is an LCD or something else at the moment. Yeah, it is. It's strange how they've done it like this. Looks like I have to unsolder all the LCD, because the shield is locked with the LCD. So then just might as well take the LCD off only. I can't believe it. They bent the first two pins when they installed it. Okay. So there you go. Oh shit. So there's the LCD off, and can't believe they did this. You can see just inside there's the globes. What a bastard that it's like that. So you have to remove this whole thing really, yeah? And you definitely have to release the LCD screen off first. So the probably globes, I can replace them like that, but I'll see if I can fit something better than those globes, but yeah. Okay, so I unsoldered the lamps are still there, but I desoldered the circuit board from the back. See if I can remove the lamps. Son of a bitch. That's one globe out from there. Now the other one. The other globe. Okay. Okay, this is the new lamp that I have. The wires are a bit thinner. These have stiffer wires, which sort of they're better. But I don't have these lamps and probably can't get them. So I'm going to have to fit this. Otherwise it's too much mucking around. Alright, before I put the LCD screen back on, I just tested it. Okay, so there's the globes now running. The new globes. Yeah, so I'll put the LCD screen on now. So I'm going to solder the LCD screen back on. Yeah, sure that's how it was. Keep going. Okay. It's pretty good. If the phone can focus. Anyway, let's put it back on. So now it's a matter of testing it. So I'll give it a quick test. Okay, so I'll have to temporarily put this on. Okay. So I'll just plug it on and see if it comes on and shows properly. Power, tuner, it's not very bright, but I think that's how it is. CD, video, tape, that's showing, FM, CD. Okay, so that's back, switch it off, back on. Okay. Okay, so with the CD-S370 sharp unit, I decided to put a Bluetooth, I want to install a Bluetooth chip here, module, connection, and I'm going to hook it up through the auxiliary input. But this thing needs 3 to 5 volts, 3.3 to 5 volts to work. And unfortunately the system, the 5 volt is not switched, it's always on, and it has got a switched 5 volts, but it's actually a control power 5 volts, so it's run from a small transistor, and I don't want to be, this thing takes about 20 milliamps, so I don't want to be overloading that circuit because it's used to control the switch part of the circuit. So what we're going to do here is just looking at the circuit. I actually downloaded a circuit diagram actually. I happened to find one. So that's the main power supply there, and you can see of the bridge rectifiers there on pin 5. Okay, it feeds these two transistors that power up the 12 volt systems, one for the tape deck, the motor, and the analog. So it's 19 volts, and it regulates it here to 12.4 volts. The other one's 11.8. Runs off the same line, pin 6 here and pin 5 there actually. I don't think you were seeing that. So that's the, where are we? Regulation part. So if you can see there, Q660 is the regulator. So I'm looking at Q658, which is the analog, and this one Q659 is, I think it runs the tape deck, 12 volts there. It's got amp probably for the motor, and it's switched. So when you have the power off, this 12 volts here is off. So what I'm going to do, because it hasn't got a 5 volt switched circuit, okay, so I don't want to be connecting it to the control circuit, which is okay, let's see. Shows the 5 volts power circuit, if I can see where I am. Okay, up there you can see where it says power control line. So that's 4.9 there, but that is used to switch all the inputs on. So this supply 4.9 is coming from the front board, the control board, and it's supplied by 5 volts, which is always on, so it's not switched, and the microprocessor turns another transistor on to get this 4.9 volts here. So when the power is off, there's no 4.9 volts, and when the power is on from the switch, you get 4.9 on the standby. Okay, so when standby is on, and then that circuit, that power control line, as you can see, it comes down here and starts switching, turning on different transistors to put power on. Now that's, of course, is another 15 volt supply, but I'm after 5 volts, so I can't have higher than 5 volts. So if you see the control line, where are we with this? Yep, it's going to come down there. Okay, there. Okay, it's turning these regulators on here, and I'm going to be connecting it to here, to the motor side. So once you get the 4.9 here volts, this regulator comes on and regulates this transistor here and turns it on, regulates it to 12.4 and 12 volts there, right? 11.8 on this one. So I'm going to be hooking up to that point. So I'm going to have a 5 volt regulator, okay, just there in front of that, and that's going to feed the Bluetooth module. So where are we? We're going to feed this power here by having a 5 volt regulator on, powered from Q659, if I'm saying right. Okay, now, so what I did, I'll show you on the circuit board here. I didn't film soldering because it's too long and it's too hard to get the camera right. And that's my 5 volt regulator there. Okay, it's coming from the 12 volts. So let me zoom out. Where are we? No, right now. There we are. So it's a 5 volt little regulator, TL92. I just got a 0.1 microfarad capacitor on the 12 volt side, and I put a 10 microfarad capacitor on the output, which is the 5 volts, and the middle section here is ground. So I hooked up a ground to the main ground, a ground there. So that will feed the Bluetooth module. I'll show you again. Okay, now the Bluetooth module, I'm going to be mounting it. I've already done a base here. So this is on the inside. And put some lights here. I've put a little plastic stud here with a thread. And I had to drill this hole slightly bigger, the mounting hole, because it wasn't enough for a 3mm screw. and that's going to be, it's going to mount there. Okay, right behind there. So that's where the Bluetooth module is going to go. Okay, so I'll just put it there. Let me put some more light here because I can't even see myself. Okay, that's inside. That's the power supply there, just the AC in, transformer and rectifiers, and then this is the regulation board here and the power amps and all that stuff. So now I ran the wire. Okay, the front face goes on here. Okay, that's off, and I will be soldering the wires to the 5 volts and the ground, just there on my little regulator. Okay, so that's that part. Okay, so I'll be soldering the wires here. The ground first. Okay, so I've hooked up the 5 volts, and let's see what I can do. So I've already tested it, but just to show you, I'll have that on the 5 volts and put the power on, and we get the 4.972 close to 5.7, sorry, 0.97, and the 12 volts will be on that point there, which is 11.42. okay, so the Bluetooth module should be flashing. Let's see. And yep, so that will be ready. I have to hook up the output terminals right and left into the auxiliary, which I'm going to run it through a 47k ohm resistor. And okay, so here is where I put the connected the Bluetooth output to the input of the auxiliary of the stereo here, the sharp, and I've run it through a 10k resistor after the original input of the 47k, and so that's right and left. So, and it's a shielded wire which goes to the Bluetooth. At the top, I'll just remove this cover here, and there it is there. So the CD is back in, everything's back in, and it's all working fine. Everything's been serviced. The CD, as I explained before, I had to give the laser diode a bit more current, so it's a bit tired, and fixed up the tape deck, cleaned the pinch rollers, polished the heads, cleaned all the tape oxidization of the heads, and cleaned the mute switches because when you were playing it, the sound was cutting off because there's a couple of mute switches on each side A and B. I had to do that as well, and clean the belts. The belts are still in good condition, and the CD as well. I had to clean the rubber belt of the motor that runs the mechanism tray, and the switches that tells it to senses when the carriage is all the way out and when it's all the way in, so it stops the motor. That was faulty as well, so I had to clean the switches. Okay, and that's again the 5-volt line to run the Bluetooth system. So it's just a 5-volt regulator there, and yeah, running off the 12-volt switched system of it. So getting back, so as you can see here, the input, it's got a 47k ohm resistor. So I didn't connect it before that, I connected after through a capacitor, a 1 microfarad capacitor, and a 10k resistor, and then hooked up to the input. So if I had to make a quick diagram, okay, so the way I've hooked it up is this way, left and right. Okay. Make that a bit bigger again. So the input is run like that, through a capacitor and a 10k resistor, and then the end of that 10k resistor hooks up to this section here. Because as you can see, it's being attenuated anyway with a 1.8k resistor here to ground, left and right. So that's why originally I was going to run a 47k resistor, but the level was too low. Obviously this is suited for a video input audio, so it's a bit high, I suppose, and they want to, bring that down, that level. So that's how that's done. Okay, end of video.